So today I'm going to teach you how to solve quadratics where a isn't equal to -1. So just as a reminder, a quadratic equation is ax squared plus bx plus c. And in the last video, we were all solving something like that. We were solving it and factoring it. Now what I'm going to do is I'm going to throw a 2 in there for the a. So it's going to be something that is a little bit more challenging to factor. Okay, factor the trinomial. So there's a method here, and I call it the 5-step method. And it's called the 5-step method because there's 5 steps to it. And every math teacher has a little bit of a different way that they like to factor these. So I really like this method. You take the 5, you multiply it to the 10. So I have x squared plus 27x plus 50. Now we start looking at our factors of 50. And some of you might be able to do them in your head, some of you may not. The first few, I'm going to be listing out the factors of 50 and then looking at their sum. So 1 times 50, obviously that is 51. 2 times 25, well, that's 27. So x plus 2, x plus 25. Now what we've done is we've manipulated this 10 and made it a 50, which has manipulated both the 2 and the 25. What you need to remember to do, and this is the biggest thing you need to remember, is you need to divide both of those numbers by 5. And then reduce. So the 1 on the right reduces, 5 divided by 25 reduces to 5. 5 doesn't reduce at all. 2 over 5 doesn't reduce. So that 5 comes up and becomes a coefficient. So now that's factored. And again, remember, you could FOIL this out if you wanted to check your answer and make sure whether or not it was correct. Okay, another one. And again, I want to highlight that I want to use the 5-step method here. Okay, so I take and I multiply the 3 to the 14. Now I need two things that have opposite signs. The reason they have opposite signs, again, remember, is I have a minus there, so I need a positive and a negative thing that are going to multiply to be 42, and then they're going to add to be 1. So let's think about this. So you don't really always have to list out the factors. If you think, okay, what two factors are really close together because their difference has to be 1 that are going to be multiplied to be 42, well, that is -7 and a +6. Now remember to divide by 3, and then 7 over 3 doesn't reduce, that 3 swings up and becomes a coefficient. Then 6 over 3 reduces to be x plus 2. Okay. There's a method that I learned in high school, and it's called the trial and error method. So if I take the 5, I'm going to do it both ways with you guys. So first I'm going to do the 5-step method. So I take and I multiply. And then you just have to start looking at multiples of 175. So it took me a little bit, but it was n plus 25, n minus 7. I divide by 5. Five over 25 over 5 reduces. 7 over 5 doesn't reduce, so the 5 swings up. So there's also what I call the trial and error method. And this one is a little bit more complicated. Some of you might like it, but if you look at it like this, okay, so I know that the term here and the term here have to multiply to be 5. So 5 is also a prime number. So I know one has to be 5n, one has to be n. Okay? And then the terms here and here, one has to be positive, one has to be negative, because I have to multiply to be a negative number. But you start testing factors of 35. So 35, you can test 1 and 35, 2, 3, 4, 5, and 7. Since you don't have that many factors, it's now just a matter of trial and error. So I am going to guess that, and I know what the answer is, so I'm going to guess incorrectly. I'm going to guess that I have to do minus 5 here, plus 7 there. So then what I have to do is I have to check my middle term. Meaning I multiply 7n, I multiply that, and when I simplify that, I get a negative 18n. So I know I've done something wrong because I don't have the correct middle term here. But what I do realize is that it's just the opposite of what I need. So meaning I can change this I just switched the signs. So originally this was a plus, it was 5n plus 7 and n minus 5. So I want to change it to 5n minus 7 and plus 5. So if you're comfortable with the trial and error, it's like a guess and check. You can use that method. I'm going to be sticking to the 5-step method as we work through all of our problems. Okay, so this one. The first thing you always have to look for whenever you're factoring is there a greatest common factor? If there's a greatest common factor, factor that out. That's going to make your life easier. So if you notice, 4, 24, and 32, 4 goes into each one of those. So I factor this, and then from here, I factor even more. I don't have to do my 5-step method because the coefficient on the x squared is 1. Oh, it's also another easy one because everything is positive. Two things that multiply to be 8 but add to be 6. 4 and 2. So now factoring this trinomial. Okay, so this one, I'm going to do my 5-step method. So I'm going to take the 24 and I'm going to multiply it to the 3. And that's going to get me a pretty big number. So that's why guess and check might be easier for this one. But now I get that. Okay, so now I just have to start playing around with factors of 72. Now something you want to keep in mind is that they are both going to be negative, since I have a positive here and a negative here, and that they need to be numbers pretty far apart because they need to add to be 22. So I have it in my notes. I'm not going to play around with the factors with you guys. So we get that. Now again, remember, you need to divide everything by the 24. So now, this is a fun example. You have to reduce those fractions. So 18 over 24 reduces to 3/4. 4 over 24 reduces to 1/6. Anything that's in a denominator, remember, swings up. So I have 4x minus 3. Anything that's in the denominator swings up. And that's our final answer. Okay, on this one. Again, look for a greatest common factor. I have 4. 4 goes into 12, but 4 doesn't go into 27. There's nothing that goes into 4 and 27. So again, it's just another multiply the 4 to the 27. And we get x squared minus 12x minus 108. And then I factor this. X minus 18, x plus 6. Remembering that because I'm negative, and negative, one has to be negative, one has to be positive. And then, again, this is what everybody always forgets. Everybody always forgets to divide by the 4. So now we reduce. Now, anything that's in the denominator swings up. Anything that's in the denominator swings up. And so we have 2x minus 9 and 2x plus 3. Okay, so this one, I'm going to call this one the ultimate. So this one has all of the techniques that we would ever use. So first, remember, we always check the GCF. So that's what we check first. And 3 goes into each one of those terms. So I factor out that greatest common factor. Okay, now I take the 8 and multiply it to the 5. And the 3, just carry that 3 along. So I need two things that multiply to be a negative 40, but are going to add to be a positive 6. And x plus 10 minus 4. So then we now need to remember to divide by 8. 4 over 8. Well, that simplifies to 1 over 2. 10 over 8 each reduces by 2, so that is 5 over 4. And then don't forget, denominators swing up. So I have 2x minus 1 times by 4x plus 5. Okay, so that involved everything that we've been doing. It involved GCF. Your A wasn't equal to 1, so it was a little bit more complicated. Okay? Okay, now this one. Take the 3, multiply it to the 5. So I have x squared plus 7x minus 15. So now I'm actually going to look at the factors for this one. Factors of negative 15, and then we're going to look at their sum. Okay, so 1 times 15. And actually, I don't want to look at their sum. I apologize. I want to look at their difference. So 14. No, that doesn't work. 3 times 5. Well, their difference is 2. And then I could do like basically the negative version. So if I did the negative there and the negative there, and then what if I switch those and I had a positive 1 times by negative 15 and add them together, positive 3 and a negative 5, that's going to be a negative 2. And nothing else that I can think of goes into 15. So if you can't factor something, that's called prime. There's no other factors that go into it. A prime number, only one in itself go into that number. So if we can't factor something, then our answer is prime. Okay, so solving this equation. Now we're going to utilize all that we've learned. And we're going to solve the equation. Remember, your first step is to get your equation equal to 0. Now, look for any GCFs. We do not have any GCFs. So take the 2, multiply it to the 3. And this one's an interesting one. So don't careful on factoring this one. So I need something that multiplies to be a negative 6, but adds to be a positive 5. So that is plus 6 minus 1. Then remember we want to divide everything by 2. So 6 over 2 reduces to 3. This 2 swings up. Now remember our next step, set each one of those factors equal to 0. So I get x equal to negative 3 and x equal to 1/2. And those are our two answers. Okay, another one. I just wanted to give you guys a lot of examples. Let's do this one in green. So remember your first step is to get one side to be 0. You always also want to have your term, your squared term, be positive. Take the 14 and multiply it to the 15. Two things that multiply to be 210, but we're going to add to be 11. That turns into 21 and 10. Now again, remember you have to divide by 14 and reduce. Always, always, always remember to do that. Denominators swing up, so I have 2r plus 3 and 7r minus 5 equals 0. Remember that if one of these two terms equals 0, the whole equation equals 0. That's how we can set that equal to 0. And that equation equals 0. I add 5 over. I did that other one all in my head. And divide by 7. Okay, our last one again. You have to get one side to be 0. And then these look like really big numbers to me. So I'm going to guess that there's a greatest common factor I can factor out. And 6 happens to go into each one of the terms. So now we take the 5 and we multiply it to the 24. And that 6 again just comes along. We actually end up not doing anything with that 6. Actually, we haven't done one like this yet. So now two things that multiply to be 120, but add to be positive 7. One has to be negative, one has to be positive, and that works out to be 15 and 8. Now remember, I've divided by the 5, I've multiplied by 5, so I need to divide by it. 15 over 5 reduces to 3. 8 over 5, nothing reduces, so the 5 swings up. And swings up correctly, not the 8. The 5r swings up. Now the 6 has no variable attached to it, so we don't have to worry about doing anything with that. We set r minus 3 equal to 0, and 5r plus 8 equal to 0. To 0. And then I subtract 8 from both sides, and I divide by 5. So my answers are right there. Okay, I know that that was a lot. There's a lot to this factoring section. Thank you for watching.